In this presentation, I am going to discuss the work of Vander Planck. Vander Planck wrote quite a number of books on the subject of plant pathology, but he was mainly known for his book, which is known as Plant Diseases, Epidemics, and Control. This book was initially written in 1963 and reprinted, and the most recent reprint in 2013. This book was mainly focused on epidemics, how they occur, when they occur, and how we can control them in the plants. But along with that, he also gave new concepts in plant disease resistance, which are still valid, and you can find them in every plant pathology book, especially those books which are written on plant resistance. So it is not bad idea to discuss briefly his work. It will help us to understand resistance and the different mechanism involved in plant disease resistance. He actually in this book gave two concepts. One is vertical and the horizontal resistance, and there is a statement that disease is specific and resistance is unspecific. Why he choose the word vertical and horizontal? In layman language, vertical means some kind of erect structure, and in horizontal means some kind of parallel or plane thing. So we will discuss the reason why he chose these two phrases to describe resistance in the plants. At this point, we all know that true resistance in the plant is actually due to the presence of gene or a group of genes. And when a single gene causing the resistance in plant, then it is known as vertical resistance. And if the resistance is due to the presence of more than one gene, then it is known as horizontal resistance. Vertical resistance is a kind of resistance which is based on a single gene, and this single gene detect the corresponding a virulent gene in a pathogen, and not only detect it but help the plant to counter that pathogen, and plant become resistant against this pathogen. When such kind of thing occur, the resistance is a complete resistance or 100% resistance. Why? Because the plant not allow the pathogen to enter in it and cause any kind of damage. But this kind of resistance is only effective against a very specific pathogen, and most of the pathogens are not affected by this kind of resistance. Because this resistance is due to the presence of a single gene, in literature you can also find the word monogenic for the vertical resistance. And you can also find this resistance is also known as qualitative resistance. Why it is a qualitative resistance? Because of its high quality, as it provide 100% protection against the pest. In coming slides, I am going to discuss how this resistance work in plant. If you look at the screen, you can find a graph. At the x-axis there is a resistant gene, and at the y-axis there is a resistance, and the maximum resistance is 100%. And at the top of the graph you can find a bacteria which possesses V1 pathogenic gene. But if you look down at the x-axis, there is no resistant gene is present in a plant against this bacteria. If by chance this bacteria attack this plant, what would happen? This bacteria goes undetected, and because it goes undetected, it causes the disease. But now the scenario is different. It is the same pathogenic bacteria which previously successfully caused the disease in the plant. But if you look at the x-axis, you can find the R1 gene, and R1 gene means resistant gene that is capable of detecting this bacteria. What would happen if this bacteria attack a plant which has the R gene? So R gene detect the V1 gene, and as a result of that, it makes the plant resistant against this bacteria. because there is a erect structure and there is a 100% resistance. That is why it is known as vertical resistance. In the previous slide, we saw how R1 gene detect the V1 gene present in phytopathogenic bacteria, and due to this detection, plant become resistant. But this resistance is not permanent, and sooner than later, some kind of mutation occur in V1 gene, and it change its shapes into a V2 gene. But for the V2 gene, there is no resistant gene is present in the plant, and as a result of that, this V2 gene carrying bacteria go undetected, and once it go undetected, the same story repeated, and the plant become diseased. So this, unless and until we not find another gene, the plant remain susceptible against this pathogen. In this current slide, I tried to sum up the story of vertical resistance. In case of vertical resistance, you always need a corresponding resistant gene against the mutated copies of previously pathogenic gene. If you are one step ahead of pathogen, then you have a crop which is 100% resistant. But sooner than later, the pathogen bounce back, and if you not detect it, what would happen? Then there is a complete crop failure. And in this kind of resistance, the breeders or pathologists need to work on war footing, because any lapse from their side can lead to a complete crop failure or an epidemic. So the people always try to insert every year or the second year a new gene of resistance against the known mutated pathogenic genes. In this slide, I am going to discuss briefly about the pros and the cons associated with the vertical resistance. One obvious advantage of the vertical resistance that it is a complete resistance, and the plant if have a resistant gene, it would not allow the corresponding pathogenic gene to progress, and as a result of that you get a crop without any kind of damage. But at the same time, there is a danger if some mutation occur whether in the resistant gene or the corresponding pathogenic gene, it could lead to a complete crop failure. The second advantage of this approach that suppose you grow a variety which has a resistant gene against the prevailing pathogenic gene. This variety will and grow it on a huge area or a large area. This variety will not allow this pathogen to proceed and progress, and as a result of that, this pathogen becomes starved and eliminated from the agroecosystem. But at the same time, there is a problem. When you push the pathogen towards the wall, the pathogen will react and allow the more virulent and the mutated copies of its gene to proceed and progress, because the natural competition is gone, and these mutated pathogen will break the resistance, and again there is plant disease epidemics. Vertical resistance is always liked by the farmer because this kind of resistance give the 100% protection against the disease. And we know that farmer put so much money, time, energy while growing the crop, so they will not compromise that the some yield is lost due to the disease. But at the same time, it is a nightmare for the pathologist. And why it is nightmare for the pathologist? Because pathologists know that sooner than later, because the resistance is built on just on one gene, that gene will break and it could lead to the plant disease epidemic. And here is another kind of resistance which is known as horizontal resistance. This is resistance due to the presence of more than one gene. The number of the genes involved in horizontal resistance vary, there may be two, three, or four or five genes in the horizontal resistance, and every gene contributes towards the resistance. Despite the number is more, but still you never get the 100% protection because this resistance is based upon more than one gene. It is also known as multigenic resistance. But unlike to the vertical resistance, this resistance provide protection against the non-specific pathogen. And usually in the field, we witness the horizontal resistance. The other name of the horizontal resistance is quantitative resistance. In this slide, I am going to discuss how this horizontal resistance works. Here you find three resistant genes, and these genes are not there to by keeping in mind about the pathogen. So they are there and they are contributing in the resistance. Every gene contribute maybe 20, 25, 30%, and even that gene is lost for any reason, but still there are other genes which provide 60 to 70% protection. It is almost impossible that at the same time in a single individual plant all these three genes become mutated and lost their property of resistance. At the same time, it is also not possible that in a single strain of pathogen or a single individual pathogen has corresponding mutated copies of these three genes. So that pathogen may have one gene which can break one of these genes, but still 60-70% protection is available for the plant, and as a whole the plant remain protected, but never in the horizontal resistance you can get 100% protection. Horizontal resistance has its own advantages and disadvantages. One of the advantage of the horizontal resistance is that it is an incomplete resistance and not based upon a single gene. So even one gene is broken, but still the other genes are there to protect the plant against the pathogen. So if there is an incomplete resistance, the failure is also incomplete, and at the end of the day, we will get something. Uh, the second disadvantage probably associated with this kind of resistance, that this kind of resistance never target to eliminate the pathogen from agro ecosystem. It always offers something to the pathogen so that the pathogen survive, but at the same time it check the pathogen so that it will not cause a complete kind of failure. So the basic idea in case of horizontal resistance is live and let live, geo or gene do. So it not put the pressure on the pathogen, and as a result of that, pathogen will not allows the mutated copies to flourish, and both plant and pathogen live together. Uh, it's actually always liked by the pathologist because pathologists think because the resistance is based upon more than one gene, so it would be rare chance that epidemics can occur. But the farmers usually don't like horizontal resistance because they think despite putting so much time, money, energy, their part of their yield is lost due to the disease, and pathogen is also present in the field which every year causing some kind of damage. Over the years, plant pathologist or the breeder reached to a conclusion that we should exploit both horizontal and vertical resistance in order to get maximum protection against the pathogen. So if you look at the slide, you can find two genes, R1, R2. These two genes are providing protection against the pathogens, and now the breeder and pathologist target the prevailing pathogenic species that carries the V3 gene. So they incorporated a vertical resistant gene against it. So a 100% protection is available against against bacteria which carries the V3 gene. If somehow with the passage of time there is mutation occur, even that resistant gene is broken up, but still the backup is there in the form of R1 R2. So this strategy is now popular among the pathologist or among the breeder who's specially working in the rust diseases, and they due to this exploitation we have the varieties which usually provide the protection against the pathogen. I hope that every one of you has a very good idea about the vertical and the horizontal resistance and how these two approaches work in plant disease resistance. What are the advantages and the disadvantages associated with vertical and the horizontal resistance, and how we can manipulate both these approaches for better protection against the pathogen. Now I would like to discuss another concept which was initially given by Vanderplank almost 57 years ago, but still it is accepted by the pathologists around the globe. What was his idea? He told us that disease is specific while the resistance is unspecific. So I tried to elaborate it in the much simplistic manner by giving you the example from our own daily life. Suppose I divide the class of resistance against plant diseases into two groups. To first group, I give them assignment to provide me the list of wheat diseases. So, and the second group, I give them assignment to provide the list against which the wheat showing resistance. So, what would happen? I'm pretty sure the first group come to my office the very next morning with a list, and this list carries the name of all diseases so far known by the scientist which able to cause damage in wheat plant. So if you look the list, you probably find 90 to 100 names. So do you not think it also mean that the wheat is susceptible against these specific diseases whose number is 90 or probably 100? So we can in other sense also say disease is a some kind of a specific thing. Guess the reaction of the other group, whose title of assignment to provide the list of all those pathogens against whom wheat is resistant. Can they complete this assignment? No. Why? Because there are thousands of pathogen and probably their number is unspecific or their number is indefinite. And it is not possible for anyone to write down the name of each and every pathogen against whom the wheat is resistant. But we can't take away that they are not pathogens. They are successfully causing the diseases in other crops or other plant. But the only issue is that they're still not able to cause disease in the wheat plant. So probably this group will never show me the face because they can never complete this assignment. So, in short, what the Vanderplank said or concluded that disease is specific and the resistance is unspecific. Why? Because the plants are only susceptible against a very tiny minority of pathogens in a community of thousands of pathogens. So this statement still blindly accepted by the plant pathologist as a norm all over the world. So here is the link where you can find hints or notes what we talk about. I already put them on the university portal. But yesterday when I checked, there is an issue. I will double check, and if there is an issue, I would again put it on there. So till then, have a nice day and bye.